Welcome to the Data Future channel. Uh, this is Shekhar and I am a data scientist. So in this particular tutorial, we are going to develop a machine learning model which can predict the milk grade. So basically it's a multi-class classification model we are going to develop. Okay, so let's get started. Yes, as usual, the first step is we need to import the required modules or the libraries we can say. So basically pandas, numpy, matplotlib, and seaborn. Then second thing is we need to load the data. So my data set is here in this particular file, and I'm reading it by using a read underscore CSV. Okay, and I will see the first 5 rows. So this data is very simple data I have taken to understand different aspects of machine learning model, right? So now you can see here, this is the data where the pH, temperature, taste, odor, fat, turbidity, color, and grade. So grade is our target variable here, so which can have the three values basically high, low, and medium. There is a and rest of all are the numerical columns. But if you can check that here, the pH, temperature, and the color is having some different range, and the taste, odor, fat, turbidity having the 0 and 1 values. So we'll see that. Here I'm printing the number of rows and columns by using a df.shape. So 1059 rows and 8 columns are there. So I will print the list of columns by using this. These are the columns. Now I will print also the which are the categorical columns and which are the numerical columns. So based on whether it is object or uh, not object, right? So you can see that uh, only categorical column is grade and rest of all are the numerical columns you can see here. So we want to see the data types from this. You will get the data type. This is the float, all are integer, and this is categorical column. Then we can see the information about the data. So from this, you can see that there is a no any missing values, and you can see the data type also. So here we are checking whether there is a duplicate records present in the data set or not. If we can check df.duplicated function is there, dot .any, it will give the true and false. If it is true, then duplicate rows are present in the data set. And if it is false, then we can say uh, there is no duplicates in the data set. So duplicate rows are present in the data set. So we can display the duplicate rows by using df in bracket df dot duplicated. So we'll get all the rows. So there are maximum rows are duplicated, so we need to remove this. So our data becomes very simple. Okay, okay, that's fine. So here we are removing the duplicate values. So by using a drop duplicates. Okay, and we are checking what is the shape. So you can see that we have drop duplicate and we have keep only one record. Okay. So here the remaining data set is 83 rows and the 8 columns. Okay. Here we are checking any missing values present in the data set is null.sum. So it is showing all values 0 means there is a no any missing values. We'll see the statistical measure of the numerical columns by using a dot describe. So here you will get all the values of mean, median, standard deviation, these values, minimum value, maximum value. But pH, temperature, and the color, this will carry some important information. So we can see that the minimum value for these cases, right? So, but what I want to do, so I want to check based on the final value. I want to see. Uh, uh, I want to see these values, right? So here I'll put this. So I'm using a group by function here. So with that group by, I'm doing it according to grade, and it will take the mean value, and then I'll transpose this. So you will see the pH you can see for three categories like high, low, and medium. You can see for high grade, the pH average value is 6.66. For low, it's a 6.72, and medium is 6.62. For high grade, you can see there is a minimum temperature. Low is very, very high temperature, and medium is again in between these two. And color, you can see the color is color range is 250, means greater is low, and for medium it's around 250. Okay, so from that also you will get the idea, right? Then you can see the unique values in the each column. We are printing by it by using a value count. So I am running the for loop and just printing these value counts. So you can see that for these particular cases, the pH value and their count, you can see the most of the count is for 6.6 pH values. Then this is for temperature, 45 is the greater temperature. Then you can see these values, 65 is the highest temperature, which is having the, 90 is the highest temperature. Okay, now you can see the test values is 0 and 1, order is 0 and 1, fat, turbidity, color, and grade. So you can see that our data set, our target variable is high value 23, low is 26, and medium is 34. Okay. Then you can see these columns are there. Now I want to see, uh, I want to check based on the grade, what is the values of this taste, odor, fat, and turbidity. So here I am using a pd.crosstab, so it can compare these based based on the numbers on the different uh, columns, and I am going to plot the bar plot for each column. So when I run this, you will see, okay, so first graph you are getting for this test. So you can see that for the test, it's a 0 is 1, 0 and 1. So 1 is good test and this is the bad test, we can say. So for high, you can see the most of high having the more difference between 0 and 1. So low, it's a equal 1, and for medium, it's again there is a difference between those, so the bad test is more. Okay, then same for the order. So you can see the order is 1 here. So here for the low, its order value is great, and for the medium is huge. The same thing for fat level, you can see the high grade milk is having a high fat, then low grade is somewhat lesser, and medium is again it's less. Turbidity means it's just like a cloudy ness or the cloudy structure of the milk, haziness we can say. You can see there is some value is there, right? So this is all about this comparison. So you can see the grade value points. So already we have seen, and we can plot the bar graph also for these grades. So highest is medium, low is second one, and high is third one. So I want to plot the histogram for these numerical columns by using this tf.hist simply. So you will get this histogram. So the pH and temperature and the color is carrying the meaning. So all are these are the skewed values are there. Okay, so box plot, we are going to plot box plot for these for pH values, Uh, yes, there are a lot of outliers are there. Then temperature is there is outlier is present. This taste order fat and turbidity is 0101, and I think color is having no uh, outliers. Now I want to plot this bar graph in the one go by using this. So you'll get three bar box plot here for three columns. Okay. Now this we already done. Okay. Now next one is you can see this data. Now from this data we are having one categorical column which is the target one. Now we have to convert this into a numbers. So we have to encode it. So high means I'm putting 2, the low means 0, and medium means 1. So you can see that. So I want to convert this. So for that I have written this function where you can see x is equal to high, then it will return 2, x is equal to medium, then return 1, and else return 0. Then I'll apply that function to this particular column, apply lambda x and grade. So in lambda function I'm using to apply this to the column, and finally you can see final table with this encoding. You can see there is a grades are now changed. Now here we are splitting the data into x means independent variables, y is dependent variables, or it's a target variables. So what I'm doing, I'm dropping the grade column from that from this, so it becomes x values. X values up to here is independent features, and grade is your target one. Okay, so this is x and this is y. Okay, fine. So next one we have to split the data into training and testing. Uh, for that, what we are using a train test split function. So X train, Y train, X train, X test, Y train, Y test. Here 22% data we have to 20% data we are using for testing, and random state is 42 and stratify is Y. So when you run this, you can see the 66 data, 66 rows are used for the training and 17 is used for the testing one. Okay, so after this one, the main part is model development. So here we are going to develop nine models, and all are these classification one. So you can see that first one is the logistic irrigation, second one is the decision tree, third one is the random forest is from ensemble, extract tree classifier is also from the ensemble. Then there is the SVC support vector machine, the classifier, the k nearest classifier, k neighbor classifier, the gradient boosting classifier, multinomial naive Bayes is there, and there is a AdaBoost classifier is there. So these models we have imported. Out of that, four models are from the ensemble techniques. Is a tree based, but ensemble means it's a parallel learning, we can say, or combined learning. Then this is tree based, this is linear model, this is from neighbors, this is naive Bayes, and this is a support vector machine. So run this. Okay, now we have to also import the evaluation matrix where you can see there is confusion matrix, accuracy score, F1 score, classification report, and also I'm importing here the cross-val score that is used for the cross validation actually. So here I'm creating the object of each model. So I will apply or fit these models one by one. Okay. So now our models are ready. So we have created here the object of each model, right? Now next thing is I'm creating here the pipeline. So here the I'm suppressing the warnings here. So here I'm creating the list of models. So these objects, uh, uh, I uh, I create a list of these objects. Then features are nothing but the X value, labels is Y, and cross validation I'm using a 5 force. Here I am creating a two list, two empty list. One is the accuracy list, and second one is the model name list. And I'm running a for loop. So model in the models. So first one, it will just see the what is the model name. So from model dot class underscore underscore class underscore underscore dot underscore underscore name underscore underscore. So it will give the name of this particular model. The next important part is the accuracy. So I have imported this cross-val score, and it will take the argument like first one is the model, second one is the features, third one is the labels, and accuracy criteria is the scoring criteria is the accuracy, and CV is folds, cross folds. That is, I am taking 5. So it will give you the list of 5 accuracies. Now you have to take the mean of this and multiply with the 100. So it will be converted into a percentage. And I'm appending this accuracy, mean accuracy, into this accuracy list column. And then I'm appending a model name into this model name list. Okay. After that, I'm creating the data frame from these two lists. Here you can see these two columns, and sorting that data frame with respect to cross-val accuracy, and just printing the final results. So it will take certain time because it will uh, do the 5 into 9 means 45 iterations and calculating the accuracy. 5 times for each model. Yeah, okay, and yes, we got it. Now the best model accuracy we are getting got it for gradient boosting. Second one is the ADA boost. Third one is the random forest, and very least accuracy is for SVC model. Okay, that's fine. So the best model, I'm selecting it from this particular data frame. So by using this, and you can see that the best model is this one, and its accuracy is this. Okay, fine. Now I want to see the other performance of this particular gradient boosting algorithm model. So I'm fitting it to the X-train, Y-train, and then I'm predicting it by using a gbc.predict, and I'm printing a classification report. So you will get this values for precision, recall, F1 score. These values are good, and this is the our accuracy. So here I'm going to print a confusion matrix also. So I'll do confusion matrix here. Okay, confusion matrix. Yeah, here it is confusion matrix, and I'm putting these two values. Okay, and then I will SNS dot heat map and CM anode equal to true. Now you can see there is a nice now the confusion matrix you can see for this one. So yes, there are misclassification happens for these two classes. One that is some are average, one to average are misclassified as the high grade. Okay, that's fine. Okay, now we have to build the predictive system. Okay, now yes, I have written, I am taking the inputs from the user, and I'm storing that input in the each variable, and I'm creating the list of these variables here. Okay, so and then I will use this model gbc.predict, and I'm giving the input into a list. So there should be, while giving the input, we have to provide the two square brackets. Already there is a one bracket is there and another bracket, so data becomes a two dimension, otherwise you will get the error. So that is one care you have to take. So list inside the list, so it becomes a two-dimensional. Or you can use the reshape function here if you don't want to do it like this. Reshape function dot reshape 1 comma minus 1, you can do it, right? Yes. Now what I'm printing, if the prediction is 2, then milk is of high grade. If else the prediction is 1 means average grade, and finally milk is of low grade. So let's get started. I will print the first pH value is 6.1. The temperature I will put 20. Then test is good test. Order is no. Then fat is 1. Then turbidity is 1. And color is 250. Now this data is ready. Now when I run this cell, you will see the milk is of average grade. Okay, fine. One more time we will run this for another one. So we'll use this data. Okay, 9.5, then 34 temperature, it's 1, order is 1, fat is 0, then turbidity is 1, and color is 255. So we'll see. Oh, sorry. What happens one more time it has taken? Okay, sorry. So quickly I will put this. Oh, sorry. One more time I need to run this. Huh. 9.5, 34, 1, 1, 0, 1, and 255. Okay. Now you have to run this. Milk is of high grade. It is giving. Okay. Fine. Um, One more time we'll check. 6.6, 34, test is 0, 0, 0, 0, and 255. Okay, now you have to run this. Okay, milk is of average grade. So yes, so we can build this predictive system by using this model. So in this particular model, the data is very less. So you can use you can increase the data, or you can use some complex data to build the model. But the process of building the model will remain same here. You can implement the feature scaling also. That is one case. Second one, you can use the hyperparameter tuning also. You can build this system. It's a very simple predictive system we have developed, and this is for the three classes. So multi-class classification problem model is there, right? So if you have any questions, you can ask me at any point of time, or you can directly contact me over this comment, or you can ping me on LinkedIn also. Thank you. Thanks a lot.